Today I want to do something different, and I want to talk about React hooks and specifically why I have a problem with it. So it's just gonna be a long, unscripted, off-the-cuff rant, more or less. It's also like 5 a.m., so take that with a grain of salt. Point is, I want to take a look at what React claims pure functions are, and how hooks destroy this concept and are just generally a problem. So let's look at what React defines as pure. They basically say a pure function has two property, it minds its own business. We just call that in functional programming, does not cause side effects. And given the same inputs, it has the same outputs. This also implies referential transparency, meaning that if we can always replace the call of a function with its output without any danger. For example, if we had x equals 2 plus 2, we could just replace it with x equals 4 with no downside. If we ignore runtime costs, because obviously that is a potential side effect we always have. Code takes time to execute, but we're going to ignore that one. But for example, a database lookup, we couldn't just replace with its result because the content of the database could change over time. So there's an example of a pure function. It doesn't change anything outside of it. There's no context, nothing. And they have a example of an impure function. We can see it mutates something outside of it. I don't like how they formulate it here, and this is kind of the way they try to cheat their way around the concept of purity. By saying pre-existing variable, which is, I come to that. Anyway, this is not a pure component because it clearly mutates outside state. And there they have an example how they're doing it instead. Without any states, without any impurity. And we have here a more dynamic version. It's also something people often confuse with functional programming. Is functional programming, especially under immutability often, doesn't mean we have no immutable things. It means mutability is always local or scoped to the function doing it. So like the inputs are immutable, the outputs immutable, the in-between doesn't need to be. That's a tangent. But yeah. We have no side effects here. That is correct, since we created them during the render, that is fine. And then we are getting to the side effects. And that the side effects belong in event handlers. By that they specifically mean, like, if we had an onClick here. Obviously, you shouldn't put an onClick onto a header, but these are these can be mutable, impure, obviously, because they're never executed by the component. They're executed by the browser when you click on it. But that also means we should never have a set timeout here, for example. That would be impure. We would be changing the actual event queue of the browser, which would change the outside state. But event handlers can be impure, that is fine. And we can define them in our component. But obviously, software lives, its state changes over time. We need to have a mutation, some side effect somewhere, somehow. And how that is usually done in functional programming, I will come to eventually. But in their case, it's done in event handlers first. And then as a last resort, they suggest the use effect, and the use effect cannot be used in a pure component. Neither can the use state. So I don't think they have the state section in here. I think I read a different documentation before I decided to record. I don't know where it is. But basically, short recap here again. It needs to be pure, which is funny because right underneath they say something about mutation. Rendering should be independent, that's fine. You should not mutate any of the inputs your components use for rendering. That includes prop, state, and context. To update the screen, set state instead of mutating existing objects. The problem is set state is a mutation of pre-existing objects. Specifically, it's scheduling an event in the React context. You cannot call the useState hook outside of React. That'll crash. Meaning any component that uses a hook is by definition impure. And React likes to just ignore this and then pretend that they can leverage the functional programming benefits out of it, which they can't. It doesn't work, and I'll come to a code example later that demonstrates why this fundamentally does not work and why React code tends to be a bit hard to test, for example, or hard to maintain. Obviously, that's all opinion. I don't think they have anything in here else. Yeah. So let's look at an example of a component. So if a function's input, so if we're only pure, if the output, the JSX we produce here, depends only on its inputs, then we should be able to replace the component at any point in time with its JSX without any penalty. Of course, that's not the case because this counter here, so basically all this does is a counter here that counts up every second, or we can click with on a button. It's over here. Like we can click on this. If we ignore the use effect for now and just have the state here, then depending on whatever this thing returns, and it doesn't return the same value every time, because if I click on this, if we ignore that it counts, the next time the component renders, it gets a different number. So this here is an impure function. Its output depends on more than just its input. Its input is just 0, and yet it still gives us different numbers. Meaning the JSX down here does not depend just on the name. It depends on some internal React state that exists before this component. Before this component exists is a bit iffy, depending, but before this function runs. When we're talking about pure functions, we mean the function runs. So this state exists before this function executes sometimes. Not the first time, but on a re-render. And set counter is inherently impure because it schedules an update in the React context. It mutates React itself. And React exists before the component exists. So even by their own definitions, this is just a no-go to call inside of the component. Now, of course, we don't call it inside of the component, which is fine, but we do call the use effect inside the component. And this use effect schedules this function with the React context. It doesn't execute it, but it still schedules it in the React context and changes the React context, meaning this is not pure. I know I'm writing a bit on about this, but it's kind of important. So what is the problem? Why is this a problem? Well, if we think about how to test this function, one special feature of this function is, or this component is, it rolls around at 100. So it counts from 0 to 99 and then goes back to 0. If we wanted to test what this component renders, we have no control over this internal value here. The first time we render it, it would render 0, but if it's been around for a while, the component, we have no idea what it's displaying. Due to the timer and due to the however it was clicked. So for example, if we wanted to test this roller over, we'd have to render the component and then simulate 100 clicks on this button while also turning off any timers. That is what we need to do to test this component. And that's bad. That's really, really bad. And in a pure function, where its output would only depend on the inputs, we could just, this would be a parameter here, in here. And I'll show an example in a second on how to solve this. Actually, I can just scroll up. Here's a solution that is possible to do in React. It's just a thought experiment, and I'm not suggesting to do that. But we can see that the counter here is a parameter, and so is the set counter. It's an input to the function. And we're gonna ignore how this component is created here. This is framework code that I wrote myself. And then we see the use effect. It doesn't change anything. It's just a return value. We're not registering it anywhere. Whatever framework executes this component can choose to run this code or not. So we're truly not mutating anything. And if we render this thing with its parameters here, then we can render the JSX, and it truly only depends on its properties. So we could render it with value 99, and then click the button, and then test whether it actually rolled over, because it called set counter then with 0. Same, we could test whether the self-update function here functions correctly by just executing it, and we'll look at the tests in a second. I want to return to this thing here. So, how would we test this in traditional React? Well, we can't, because we have to, this value is hard-coded inside the component, we need to get rid of it. So first thing we do is to extract basically everything into, oh, I had replace in. Okay. Into a custom hook, and then we can just return counter and set counter const, please. And okay, so if now we can mock this function, but for that it needs to be in a different file. But ignoring that, now we could mock this function to test this component here, and we could mock it to return any number or value we want. And then we could also test the same case if it on manual click rolls over. But how do we test this line of code? we can't. There's really no good way of testing this, because we cannot set up the state. We could maybe extract this into an extra state, basically just a thin wrapper on useState to mock it, because we don't want to mock useState itself out. That usually causes a lot of issues with other components, like child components, etc., because we in React also always render the entire component tree instead of doing shallow renders for tests. It's another point I disagree with, but I'm not going to get into that one. But basically we'd need to do a ridiculous thing where we extract this again into a custom hook, again in a new file. Something like this. And then we could replace this with the use counter state. And then we could mock this thing away, ignore the input here, and then we could set it to whatever we want. And then we could test this on value 99, let one tick expire, and see if it actually called the set counter in this hook. So we needed to make 3 custom hooks, spread them over 3 files, and write multiple mocks to just test this very simple component. And that's why tests in React are not nice, in my opinion. And also why they focus heavily on integration tests, because to unit test a component is absurd in React, like any non-trivial component. So if we take a look at my example here, which is built in 3 steps, we basically have some framework code which tells us what kind of state we need. That is registered with React, but that is not something the component does. Okay, let me go quickly to a file and talk about how this is done in functional programming. And we'll recognize this pattern here. So usually what we have is we have some input values, right? And that would be some impure read. We're reading from somewhere, React state maybe, or a database. Then we have our result and call our pure function with our input. And this thing can properly be tested. This has all the benefits of pure functions that React wants its components to have, but it doesn't have. And then we can write impure the results back to somewhere. This is how it looks in functional programming usually. We have some impure read, a pure operation, impure output, write. So we can kind of recognize this here. We have here our impure read that sets up the reading in the framework. Then we have our pure function that does something with it. And then we have our impure write, which is a function which is executed later. These are just instructions on how to write technically, but and it's like a sandwich basically. So all the tests I talked about, we can do them without any issues. If we go over to the tests here, and to just demonstrate, this is the hello world component, which is rendered here. This is the hello to world, and the other one is hello to impure world. And just to convince ourselves that both of them also work, we see them ticking together. And I should not have picked 100 as a value. And I'm not going to go to 100 now. But the tests also tell us so. We're gonna use fake timers because 1 second is a long time to wait. And we can test everything I talked about without any issues against our pure component. We're not using the React component here. We're using our own pure component. So I talked about how it returns a tuple once the markdown and the update function. In this case, we're only testing the render, so we're only caring about the markup. And we're calling our hello world with the parameters, the counter value, the set counter, and the name, the part of the hello world. And this has no internal mutation state of some sort. We render it like normal, and then we make sure the value is still 42, but doesn't need to be here. I wrote multiple tests, ignore that. And then we check if 42 is actually on the screen and if the text get by hello world is on the screen. There are better ways of writing these tests, but it's kind of quick and dirty. Then we can test if it on-click increments, and we can do that here simply. This is similar to how we would do it in React. We just render it, and then we check if the update was called. In the case of React, we would now need to basically re-render the component, check whether the component rendered the 43, etc., because it's impure and mutated. In our case, we can just check whether the set counter basically here overrode the value, which it did, to 43, if this passes. Spoiler, it passes the checkmark screen. But I'll run the test anyway to just convince ourselves. Yeah, so it passes. Now the more interesting thing, which is basically impossible to test with the with React, and that is the wraparound here, because we need to click 100 times. In our case, we can just set it up on value 99, and then click once on it, and then we can check if our value wrapped around to 0, which in our case, it does. And in React, we need to have a loop here that clicks 99 times for us, then click one more time, then verify that 99 is on the screen, then click one more time, and then verify it changed to 0. I hope you can already tell how this is convoluted at best. And just imagine you have a more complicated, more complex component where to get the component into the right state you need it for the test just requires so much setup that it's just nasty instead of just having it as input values. And yes, there are these attempts of splitting them apart into outer and inner components, etc., but at some point of time you want to have your stateful logic container also under test, right? Yeah, whatever. Here the auto update, we get the update function back. This time we care about it. We expect that there is an update function. We expect its dependency to exist. It basically replaces the use effect, has the same logic and semantics here. Then we call the update. We let 999 milliseconds elapsed. That means the timer shouldn't have triggered yet. Should still be 24. Then we let 2 more milliseconds elapse just to be safe. And then we expect the time to have changed. So we verified that the time ticked over. We can still do that in the React component, but we can only test from 0 to 1, or we need to set up again a loop and click at advance the component to a state we need it to. It becomes really difficult when you have multiple API requests. And this is the more interesting is, does the automatic ticker wrap around on 100? And again, we can just set it up to, it's the same test like here, we set it up on 99 and then we verify that it wrapped around to 0. It's simple, we can just unit test this component and we know it works now. these two functions. I wouldn't want to write the React tests for this. And as you can see, I didn't write them. And sure, I'm not that much of a front-end dev. It's just something I do out of necessity. Maybe someone can come along and say, you're a complete moron, listen, this is much easier, you can do it that way. Sure, probably. I'm also not suggesting to replace it. Anyway, it's kind of where I wanted to get to. I think it might be interesting to look at the background and how this all works. I'll be committing this code and I'll be linking it, and you can read it if you want. I wrote a comment. We can see I already also wrote down the sandwich here. Basically, a pure component is just a function that returns a React element and a update, or just a React element if it doesn't have update logic. And a update logic is just either a function, which is like in React, the use effect, either it returns void or it returns a cleanup function. And an optional dependency array. This stuff here just wraps, since it's either sometimes in a array, sometimes not, this just makes it always an array and the second part is undefined or not. Here. That's all it does. So if we look at the state, there's a bunch of helper types. The important type is this component for, which allows us to infer the arguments for a component. If we look at here, here, you can see from my type hint here and from the autocompletion that there's typing support. And this is what the component for does. It makes sure the typing set up correctly. Right, we have a component builder and we can register state. This can be extended to register more side effects or even contexts or whatever. This is extendable. I just did the minimum example with state because it's the simplest, straightforwardest one. I'm noticing things are going off to the right side of my screen. It's just React element on this side. But a with state accepts a name and an init function, just like use state does. Basically, all we did is we moved use state out into a framework around it. And that returns a component builder with these values added, the state and set state values. And the toReact component takes a pure component, or rather a component that is inferred from this component builder with its own props, and returns a React component. That is just standard React component. You have a thing that accepts props and returns a React element. Helper function to capitalize something in a typed way. Right, here's some magic, and that is the state to props, and that is for we need the variable, like in our example here, counter. We want to turn that to two properties, one counter and one set counter. This is what this does. We have the counter here, we keep the key, and it stays the value. And we add another property here, which is then set to set capitalized counter in this case, and accepts a the update function. This looks exactly the same like the dispatch in set state, except that it always accepts the previous here. Helper function to set up a name of a component, so that if we look at here at the components that we see, they are actually like, it has inherited the name hello world here with state wrapper. This is terribly small, but yeah, it sets up the name. We could capitalize it if we wanted to. Here's the magic code I'll go over after finishing up with the component builder. Why is this all going off to the right side? Anyway, shouldn't have done that. Basically, it has to, the component builder starts with an empty state. And we just extend it every time we iterate. And it's just the key to the initializer value. And that's all what we do. When with state is called, it just calls the component builder again here. And keeps the old state and adds the new property and the new init pair here. And then this is just the typing to satisfy this. We basically add t here, and we also add the key value pair here. The toReact component here just calls the with state. It does literally nothing else. And returns that. And the with state is a hog. So let's take a look at the with state. As a parameter, it takes in some sort of state. That is the external React state. And it takes in a component. A pure component in our case. Doesn't necessarily need to be a component, but it needs to be compatible with a shape. And what it returns is the impure sandwich on top of it. And we are exposing the state props here as part of the interface on the pure component. So, sorry for the tangent. These are hidden inputs. We have no control over these inputs. They're hidden. There's no way to set them from the outside. They're not hidden inputs in this case. There's still hidden inputs in hello world, but hello world is fine. This is impure, this is React, we don't care. This is the thing we want to test. Anyway, let's come back to here. So we're setting the display name. It's just setting display name here based on the function name. Then we want to run this in the same order every time, and I'm just thinking that we should probably move this out here for performance reason, because there's literally no reason to do this every time. This could be also a const. Then we take in the parameters we got, and we keep them, and then we add our inner loop. We call useState, and yes, useState in a loop, but it's not conditional because these values never change. This is fine. Usually if you see useState in a loop or an if statement, you should get a bit nervous. But since these are hard-coded, well, they're not hard-coded, but for this function, these are static. The loop will run through the same way with the same values every time. So this is fine. Before you get nervous. And then we assign just the state to the key itself and the setter to the set capitalized k here. And then we assign that to the setter. It needs to be split apart for typing reasons a bit, because TypeScript goes nuts otherwise. Then we have a lot of inferred types, which makes this line very long, which it's actually not. It's just 70 characters long. This line here is the 120 character line. But anyway, we just run the component with its parameters, because we can just do that. We could do caching here if we wanted to, but whatever. And then we get the JSX out and the update function and the dependency array. If we call a use effect with a dependency array, and then if the update function is defined, we execute the update function and return the cleanup function. It's just standard use effect here, basically. And then finally, we return the JSX. Now, since this is all framework code, this is not something we're interested in testing. We can just assume it works. Well, as the framework writer, I should be testing this, but as the user of a framework, we can just assume it works. So when we use the when we test hello world here, we never need to test this hello world, because we trust that this and that works. So we just testing the behavior here, and one could write more utilities and better utilities to actually test it and derive things from things, but that's like something I did in a few minutes now, I think. Right, so maybe this is a bit of interesting code here. I don't know. I forgot my point. Right, use state is bad. Use effect is bad. I don't like them. They make a component basically hard to impossible or to obnoxious to test. And that's it. If you like what I'm doing, if you want to hear more rants, leave a comment. Feel free to subscribe. Come into my Discord. If you, I don't know, it's early. Late? I need to go to bed. Goodbye.